Hey everybody, welcome to my shop. Well, hey everybody, it's Tom here. We are back in the shop for another project. That means another video for you guys. Fairly simple project. We've got a drive shaft repair. So let me move the camera around and show you what we got to work with. So what you're looking at is a front drive shaft off my friend's buggy. What a buggy is basically it's a hand-built four-wheel drive vehicle. Think of it as like a Jeep, but it is not street legal because you build it in the shop. It doesn't have a VIN, doesn't have a tag, but you build it to any specification you want. So it usually has a lot of flex, a lot of horsepower, big tires. And what happened is, because he's got a lot of flex, the drive shaft is able to contract and expand on these splines in this spline shaft, internally spline shaft. Well, once you get maxed out here, obviously you don't have much strength, and that's what happened. If you can see this crack here on his splined yoke. And of course the GoPro battery is getting ready to die. Hold on guys, let me put a fresh battery in. Okay, we're back, fresh new battery. And let me hold it this way so you can see. So this is the internal splines, and hopefully you guys can see that crack. So the plan is, this is going to be his spare drive shaft. So we are going to make a sleeve for this here, and then we'll just weld her on. That'll be plenty strong, and it'll work as a trail spare. I've got this hunk of 2 1/4 inch round. Not sure what it is. Mystery still at this point. Once we start machining it, we'll see if it's 1018 or something a little bit better. And like I said, we'll bore it out to the diameter here, slip her on, and weld her. We'll be good to go. Simple job. So let's get over to the Monarch and get some chips flying. Figured I'd go ahead and just cut the piece down on the bandsaw, save the material. Nothing fancy, just hanging out. Got the piece chucked up, just gonna get a clean face. The saw didn't cut it straight, or this is a different saw cut, this is not mine. As you can see, it's not anywhere close to being flat, so it's going to take me a while to get a nice surface. I'll bring you back. Face is all cleaned up. Let's chamfer this outer edge. This will be a weld edge too, so alright. Now we just got to remove a whole bunch of material. Going to center drill, and then we'll step drill it to let's see, I think I've got a 1.5 inch drill bit, so we can finish with that, and then we'll bore it out. We're going to go to 1 inch, about 850 thou. The problem is, that slip yoke is a little bit egg shaped, so not totally round. It's smaller on, obviously 2 sides, and large where it wanted to separate. We've closed it the best we could, but we'll probably have to just pick a nominal size and try to press it on. So that's the plan of attack. Let me get the tailstock up here and start removing some metal. Get the center drill punched. I went ahead and turned the part around and faced the other side and chamfered it. Didn't bother to show it on camera, since but you already saw me do one side. Slowed her down a little bit. We're about 205 RPMs. Morse Taper 4 drill bit is 1 inch and 7/64. Those I scored off of eBay at a good price. So let's remove some material. Got her slowed way down. I'm gonna run some mist cooling on this. Bad when the chips here, looks like. See if I can break them. Alright, we're done. One big hole. Let me get the boring bar set up. We'll run a skim pass so we can get a true reading on that bore and figure out how much we got to take out. Boring bar set up. Let's touch off, see where we're at. Alright. Take, I don't know, 10 skim pass, see how it goes. Avenue 0. Boring bar got a little bit extra stick out, but I think we'll be okay. And of course the battery wants to die. So we got a little over 300 thou to come out. Go ahead and dial in 50 for a total of 100. Let her rip. Hot chips. I don't know if you can see that they're blue coming off of that boring bar. Grab another one. Okay, so we're over here at the welding table, and I've been kicking around a couple ideas in my head. The OD at this part here is like 1 inch and just little smidgen over 800 thousandths. It's like 1.802 to 3 to 4. It kind of varies, you know. And it's good all the way to about here, you know, where it started to crack and open up and egg shape, and then it's like, you know, 70 thou or so large. Yeah, 1.864. So you know, we've squeezed it and tried to get it, you know, as small as possible, and I was just gonna get it to just fit over it, and then we were gonna weld it up. But the problem is, you know, because this diameter is smaller, it's gonna be kind of sloppy. We could try to shim it as we weld it, which will work, but you know, the machinist in me says let's do a better job than that. So I think what I want to do is go ahead and remove the U-joint, and we'll chuck this up in the forejaw. We may have to support this with a bull nose, and then go ahead and just kind of like, you know, skim this part here, try to get it down to the diameter that's here, you know, and maybe even remove some of this damaged area here, because the splines don't start till about, I don't know if you guys can see that or not, about 1/2 inch in. So we can remove some of this damaged material here, you know, 1/4 inch or so. So I think that's what we're going to do. Let me get over to the Inco, get the forejaw on, get the U-joint out, get this set up, and I'll bring you guys over there. Well, I think I got it dialed in pretty good. Let me block the light here, hopefully you can see that. So it moves a little bit, about 1/2 thou, and there's a bad spot there on the OD, because then when we get back here she comes back to 0, and then 1/2 thou, just a blip, maybe 1 thou there. So pretty darn good for a spare drive shaft yoke, I think. Had to use parallels to gripper in here. Even my big 15-inch forejaw, if I'd have stuck that on the Monarch, the jaws only stick out another 1/4 inch. The jaws are only like 1 3/4. These are 1.5 inch. So hopefully this will work. We won't spin it too fast, and we'll just come over here and we'll clean up this area. Let me move you guys to a good location and we'll get going. Hope that's a good position for you guys. Not going to turn it very fast. You can see how bad it looks. Hopefully you pick that up. She's running true here, but she's really out of round up there. So take some light cuts, and hopefully it'll stay in its position here. Do 10. See how it likes it. Just gonna hand feed, start off with, get a feel for it. Don't want to push it out of the forejaw. Too bad. I'll do another 10. Just gonna whittle away, and I'll bring you guys back at a good cut. Getting a pretty good cut almost all the way around. We'll check it out to this pass. Sorry, went handheld, a little shaky, but here's the cleanup. I think we're good. I'm just going to clean the face here a little bit, put a chamfer on it. We'll get a measurement off of this, and then we'll know what our final bore needs to be over there for a slip fit. Got it all wrapped up, all the machining's done here on this yoke. Hopefully if I rotate it, let me kill some of the glare. You can see the crack, that was the issue here. So overall pleased with it. Didn't have any issues in the chuck, thank goodness. Having to kind of hold it this way with parallels and whatnot, but worked pretty good. So this final OD is 1 inch 796 thou. So now we can go back over to the Monarch and start our bore to about 1 inch, I don't know, 797 or so. Well, this should be my last pass. I'm going to dial in about 9.5 thou. Set my zero. Alright, let's grab the yoke. Hopefully you guys are still in frame. Almost. I think just a light skim pass. I don't know if there's any flex in the bar or not. And that should do it. Alright, we have us a nice fit, just kind of starting it. If I put her on there until I'm kind of wiggling it. Oh yeah. Look at that. Wow, that's a tight fit. Perfect. Couldn't get any better than that. Sweet. Alright, let me get this out and I'll tap her down with a hammer. And customer wants me to go ahead and weld it up. And this job will be done. So meet you guys over at the welding table. Gonna go handheld, maybe a tad bit shaky, but here's the setup. So we got it on my Keith Fenner rollers. Well, I ordered one of his kits and I built it. Perfect for this job. Ground clamp on a nice piece of braided strap there. And plan is to rotate one hand and I'm going to sit here and weld with the other. Hopefully we can get a nice weld all the way around. Let's see if I can get you in a decent spot. Let me get some leathers on and my helmet and fire this puppy up. We'll try that position, see how that works. We'll get comfortable. Yep, don't get any better than that. I'm gonna do the other one off camera. Well guys, there you go, all welded up. This weld isn't as pretty because as I was going around, the heat got into it. You know, the grease that's inside on the splines was seeping out and coming around and contaminating the weld, so she wanted to pop and, you know, be angry at it because it's not a perfectly clean surface like it was when I started. But this side is nice, no contaminants, looks good, so happy with it. And it should pretty much be in balance, or be in balance that it was when I got it. So I know the customer will be happy. This is a spare drive shaft anyways. So one job wrapped up. I'll give them a call, let them know to come get it. And with that, I'll just say, hey guys, thanks for watching. Thanks for hanging out in the shop with me. I appreciate it. Hit that subscribe button if you hadn't subscribed. And until next time, we'll see you.